Welcome to Lesson 26, Central Angles and Arc Measures. Today, we are going to learn a little bit more about circles, and our one objective is identify and determine the measures of central angles and arcs of a circle. So an arc is a part of a circle that consists of 2 points on the circle and all the points in between. So for example, arc AB is this right here. It includes A, it includes B, and everything on the circle in between A and B. We would name that arc AB, which unlike a segment, which would be a straight line, in arc we put a curved arc over the two letters. The measure of an arc is equal to the measure of the central angle. So the measure of arc AB between A and B is 40 degrees. So whenever they ask you for a measure of an arc, they're essentially asking you what portion of the 360-degree rotation is the arc. So for example, arc AC is half of that rotation. That's a 180-degree arc. And you can always tell, one quick way to figure out how much of that rotation it is if you know the central angle. The central angle is the angle formed by two rays. So in between those two rays is an angle measure. So if this angle measure is 140, the arc associated with that central angle also has a measure of 140 degrees. So when in doubt what the measure is for an arc, look to see if you have a central angle. Be careful, in later lessons we'll look at inscribed angles that start at the edge of a circle. You don't want to use that as a central angle. Central angles only start in the middle of the circle and use radii, so don't get central angles confused with inscribed angles, which we'll learn about in a later lesson. But do keep in mind, central angles are always made up of two rays that stem from either side of that angle. There are two kinds of arcs, minor arcs and major arcs. Well, three actually: minor arcs, major arcs, and semicircles. Minor arcs are arcs that are less than 180 degrees. So arc AB would be one minor arc. Arc BC would be another minor arc. A major arc are arcs that are greater than 180 degrees. For example, BCA. So if I take a different color here, BCA starts at B, goes through C, and goes back around to A. Okay, the measure of angle BCA, if this is 140 and this is another 180, together that would be 320, would be the arc measure of that major arc, which is much more than 180 degrees. A semicircle arc is 180 degrees. For example, AC. So let's pick a different color here. AC here is a semicircle arc. So notice a lot of these different arcs overlap. You can do an arc in between any 2 points. So if you have tons of points on the circle, you could hypothetically have dozens of different arcs that overlap each other. But if you're ever asked to find a minor arc or a major arc or a semicircle, minor arcs less than 180, major arcs greater than 180, semicircles are 180. Postulate 14 is the arc addition postulate, which says the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So, for example, if the measure of arc AB is 30, so if this is 30, and BC is 100, well, what is the measure of AC going around the edge here? We just add the two. So this is the same concept as the segment addition postulate, where if a segment is split up and this segment is 5 and this segment is 10, well then together they must be 15. This is very similar to the arc addition postulate, which says if you have two adjacent angles, this is similar to the angle addition postulate. If you have two neighboring angles, then these two angles added together should equal the full thing. For example, if this is 20 and this is 30, the whole thing is 50. Exact same idea here. You just add together the neighboring central angles that'll have the same measure as the neighboring arcs added together. So, very straightforward concept. You can kind of group it mentally with the segment addition postulate and the angle addition postulate. This so far, hopefully you agree, is a fairly straightforward lesson. One way they make it slightly more difficult is they throw some terms inside of the angles, the central angles, and you're expected to find the measure of an arc somewhere in the circle. So, the question asks you to find x and find the measure of BC, which is actually the arc over here. So first let's worry about finding x. Notice that these two angles are on either side of crisscrossing lines, which makes them vertical angles. And we learned in an earlier lesson that vertical angles are always congruent. So, that means we can say x plus 98 over 2 should equal x minus 2. So, if we want to get the x by itself, we should get rid of this 2. One way we can get rid of this 2 is by multiplying both sides by 2, which would give us 2x plus 196 equals x minus 2. So we can subtract x from both sides, and we could subtract 196 from both sides, which would give us x equals So if we distribute the 2 on this side, it just cancels out, so we get an x plus 98. On the right side, the 2 would get distributed, so 2x minus 4. So, if we would subtract an x from both sides, we get 1x on the right, and if we added 4 to both sides, we would get x equals 102. Okay, so both of these central angles are 102, which means, actually take that back. If x is 102, then we just substitute 102 in for x, so this would be 102 minus 2, so this would actually be 100. If we would do 102 plus 98, that would be 200 divided by 2. The central angle would be 100. So you got to be careful for ones like this, and you saw me almost make that mistake. Once you figure out what x is, you should plug it back in to find out what that central angle is. So x equals 102. The measure of BC, well, you might be saying, I don't know what this central angle is. Well, together with that angle and the angle next to it, those two angles make up a linear pair. They are 180 degrees together, which you could also tell by this being a semicircle. So this one must be 80 to add up with the 100 to be supplementary. So arc BC must also have a measure of 80 degrees, which essentially uses the arc addition postulate to say, well, if this full arc has to be 180, and if one part of it is 100, the other part has to be 80. That's all for this lesson. We'll see you again in lesson 27.